Hi guys, so what we're going to be doing today is these boost modules. Well, it's a buck, sorry. So this one takes a higher voltage and brings it down. They're supposed to be good for up to about 4 amps, between 3 and 4 amps. This is how many. At the moment, I'm just loading this. Obviously, you can see I've set the voltage. I've had to drop the voltage down because otherwise it'll pull more amperage. This thing's already feeling hot to the touch. So what I'm going to do is design a 3D enclosure where I can insert a fan and obviously cool this. So what I'm going to do is I'm going to take a base temperature. We'll just take a base temperature off the cover. So it's like 32, 34 degrees. Now the front of this, you see it's like 40 something, but this side here where the work's being done, I mean, you've still got that perspex that it's going through, so this isn't the actual temperature. It will actually be a lot higher than this. But as you can see, if I just need to get it in the right part, as you can see, it's like 60 odd degrees. Like I say, we can, this really needs to be charging. These are pulling an amp a piece, so we should have to do 3 amps really. It's slightly more for some reason, but this thing's getting super hot. Like if I turn it around now and check the temperature again, you'll see it'll just be climbing and climbing and climbing until the point where it literally shuts itself down. So we need to make this more usable. Yeah, you can see it's starting to go up rapidly, and it'll literally go until it'll just shut off. So the idea is, I'm going to bring this voltage back down because I want to hold the current. I think what I'm going to do is make an enclosure, keep this top piece of this and do away with the rest, and then I'll make all the 3D models for anyone that has got a 3D printer, to be able to take this out of its current enclosure and put it in one where you're going to get the amperage. What I might just do is just run this fan here. This is a 5-volt one, I believe. Turn it around. So this is the 5-volt fan. Trying to get it to focus. You can see it's 5 volts and it's 60 milliamps. I could use a 12-volt one, but I'm not going to. And what I'm going to do is I'm going to attach this to the output of this. So only when it's outputting higher voltages this will go over. So it can't go over 12 volts anyway, and 10 volts won't hurt this. It'll just make it sing a little bit. Might get the bearing a bit warm, but should do the trick. So that's what we're going to be doing, and hopefully that way then I can charge this pack up. I did do a video on this pack. Basically I've got it set up is I've got so that's classed as like one battery this side, and then one set in the middle and one set on the outside. So obviously they're done in it's like parallel or series. I can never remember which way around it is, and it's the same on that side as well. And the idea is I charge this up on with these normal chargers, and if you look just on the end here, I've got some pins. And what I do is, when this is not charging, I can then connect them together, and that ties the outputs together, and then that'll give me 12.4 or 12.6 volts, depending on how charged it is. But obviously I've got to remove them clips when I come to charge them up normally, because it'll just short and it'll literally just charge one battery. Just one of them will end up getting charged in the end, because it'll just bridge the other two out, which is what we don't want. And also I'll just check that switched off. So the idea of this is just long. I think it's something like 6,600. It's supposed to be 9,900, but obviously over time batteries wear out, and some are good, some are not. So yeah, I literally use that. It powers my my Wi-Fi dongle, because it needs to be near the window out of the way, where I can get a better signal. Downside is I've got no power sources there. I mean, I could run a long cable, but then you get losses in the cabling as well. And I didn't want it tied to my PC all the time through USB. So I made this to power it up. On a full charge, this will last probably about 2.5 days. I just have to. I've got a couple more packs I've made up as well, but one pack's being used on it now, and this pack I'm obviously needs charging up now. This is the longer one. The other one's about 4,000, some maybe a slightly more. All the charge data and that is on here, but you can't see it for some reason. The camera won't pick up that kind of white light background. But I'll just look on it now. It's set 3,500. No, sorry, 35. Yeah, 3,500. So that's 3,500. 3.5, sorry, amp hours it's pouring so far. And obviously I want to be able to chuck this up and get the full usage out of this. So the point of this video is literally to convert this, well, make it an enclosure where we can actually get a fan in there to help cool this down, because this is really hot to touch. And obviously I can only pull about 2 amps. I'm forever having to like drop the voltage down to about 4 volts, so it's not pulling too much current, and then I'm obviously having to turn it up. So anyway, I've got it rarely at charging it at the moment. I mean, I could charge it different ways, but this is the way I want to do it, because I'm actually testing it all. I want to know the voltage, I want to know what amperage is coming out, and obviously I want to log wattage and everything else, which is what this thing's for here. Anyway, so this is the design I've come up with. The plate that I was showing you before, the top part of the Perspex is going to sit on the top here, and then the board's going to mount to this part here, so it's going to slide in the top. But then I had to figure a way then, because obviously these standoffs, I had to get away. I want to try and keep it small and compact, so I need a way of getting the fan in there. So I've just sort of made a hole here, and then that bit there we'll just insert after the fan's gone in, and hopefully it should fit, but we'll see. But that's what I've come up with. So the fan will sit this side here, and then I think I'm going to have it so it's going to blow the air in, and then it'll take the warm air out this side here. And there she is, printing away merrily. That must be the start of the pillars, I think that is. It's sort of blebbed over a little bit. And the paint setting this up seems to be alright. I should have made it so it lifts rather than dragging over. And it's stringing a little bit from the insert as well. I'll show you more when it's done. Can't really show you much while this big fat printer head's in the way. Yeah. So this is the version 1 complete. As you can see, I made a few errors in calculations, but it does work. That fits in nicely. And as you can see, I forgot to put the holes in for the 2 standoffs. So I cheated, I just put a bit of glue on there, but it's doing the job though. I'm getting 3 amps and it's pretty cool. And the thing is, now these are getting warm. So they're getting an amp a piece, but I can change that on the board. So I'll just change them resistors out and put a lower one in, and then it'll charge a bit lower. Can't handle too much. Yeah, it's doing good. Hey, she shows some really amp hours have been pouring in. Yeah, don't like to show that. That one's fine. Yeah, she's charging up now. Kind of stable, and it's nice and cool. Before I upload, obviously the STL for this, I am going to make a few changes, because I want it to be a perfect fit. So when you come to put it together, it's literally just take off the back off of this, and then just put it together. So it'll be nice and simple, and everything should fit flush as well then. Whereas this didn't. I had to kind of warm it up a bit with my lighter, and it's distorted this end here. There wasn't no, but I didn't put any supports on it, you see, so I think when I print it next time, I'm going to print it a different way around. And I think that should then give me a better result. Unless I do it in 2 pieces, but I don't fancy doing it in 2. yeah, there we go. She's nice and cold, just how it should have been in the first place. So I can push it harder now. These don't like it, they're quite hot. In fact, I'll show you how hot them bad boys are. Let's test this from how it used to be. Remember, it used to be 40 odd degrees. As you see, it's now 33 degrees, nice and cool. The air coming out of it's 23, 24. And the air going in, if I can get it round enough, it's about 23, 24. It's probably gone up about a degree. Not too bad. Maybe a couple of degrees. Say it might be that one there. About 32. Which is not too bad, but when you come to these, if I can get it on. Come on. Let's take that laser off. I don't know why it's got a laser on it. The laser ain't pointing nowhere near the thing, because if you look at the end of it, the laser's right at the top and then the, the actual gun thing's at the bottom. Oh, there we go, 60... about 60-70 degrees. Easily. That middle one's a lot hotter. It's kind of hard to aim this up whilst on the camera. 70 odd degrees, quite hot. Extremely hot. But that'll be a job for our next one, I think. I'm not too worried about them, to be honest. Like I said, I can drop the current for them anyways. But now I'm charging the pack at 3 amps rather than 2 amps. I might be able to get away with just putting some metal heat sinks on top of the chips. That might be just enough just to slow it down so it can get rid of the heat. Still not very stable, that. But it's cool. That's all I wanted. There you go. Like I say, I'll get these STLs before I put them on, and I'll fix the design a little bit. For some reason I didn't make it wide enough. Thanks for watching.